All right, we are going to look at how to find what certain graphs, so what we've been doing. So when we've been finding integrals, right, we've been finding, let's say that we've got curvy graphs, right?
Yeah.
What we've been doing is saying this is 2, this is 6. Okay, are we paying attention? All right, let's focus. So we need to understand what we're being asked to do so that when you get questions on the exam, you know what they're actually asking, right? Our lovely textbook is broken up into lovely little sections, and they're like, now you just do this thing, now you just do that thing. Whereas they're going to go, hey, do a thing, and you're going to need to know what they mean. So what we've been doing is finding the integral between 2 and 6, right? Between 2 and 6 of the area under a curve, right? The area bound by the curve and the axis. Sometimes it's been the y-axis, mostly it's been the x-axis. What happens when you have a graph that tends towards infinity or a particular value? So if you have a graph that does something like this, do you remember the name for this little line? Asymptote. So this is an asymptote. Oh, right. Still not a reciprocal graph. This would be like an exponential graph. Reciprocal would have to have another bit, right? So when things tend towards something in perpetuity, do they ever touch this line? No. So we call it the limit. This is what the graph is tending towards. So we can find some things, we can find some values as it relates to that. So let me give you an example of that. So I'm going to find, I want the integral between something and -2 of 2 over x to the 5 with respect to x. So I'm going to do exactly the same thing that we did with definite integrals, but instead of a second number, I'm just going to use a variable. Now, you don't have to use p. I tend never to use x or y because we're already using x's and y's. They get really confusing. Some people use t's or p's or whatever you want is fine. There's no rule about what you have to use. So the first thing we're going to do is actually integrate this. So, well, firstly, what I would like to do is rewrite this as 2 times x to the -5, and we're going to integrate that. So what do I get? So minus what it's saying, well, what am I doing? Okay, let's not skip steps. So let's just do it like this. Okay, all over -4. It's positive. See, this is what happens when we try and do it in our head. We mess some stuff up, okay? Wait, what am I doing? Oh, yeah. Yeah, that's, no, maybe. How ironic of me. Okay, so I am going to, I want the limits of this to be p somewhere between 2 and p. So, oh my gosh. Excellent. Okay, so I'm going between -2 and p. So I'm just going to rewrite this. Let's put this up here. So we end up with -½ as people said. So this is, actually, let's just rewrite that. So this is going to be half, and this is x to the 4, right? Because this negative power means it belongs down the bottom and it's positive. You with me so far? Okay, so we need to do this between p and -2. So just like we did last week, we're going to shove those into this now. So I have -1 over 2 times p to the power of 4 minus 1 over 2 times -2 to the power of 4. Now, I want you to think practically about numbers. Hard thing to do, I know. When you have a fraction, which number is bigger? Okay, this is obviously a bigger number. As I make this smaller and smaller and smaller, if that's 1 over 2,000, what am I tending towards? I am tending towards 0. Am I ever going to get to 0? Of course not. So what so what this is saying, practically, this number is tending towards 0. So realistically, I am just going to call that 0. And then if you do this, it's -1 over 32. So that means this is what it's tending towards, okay? So this is Wait, what am I? Sorry? Why what? Yes.
Because like no, but it's really like how much that changes and you make it smaller and smaller.
Yeah, absolutely it is. Okay, so let's have another look. Oops, what am I doing? Sorry? Oh,
Because the integral in itself is negative already, and we're subtracting that from that, right? So. Negative to the power. Negative, that's just a positive, that's positive, it should be negative.
you're right. I didn't put a negative sign up here. You are right. Thank you very much. That is correct. All right, I forgot my negative sign up there. So for the exact reason we just said here, as P increases, this number is getting smaller and smaller and smaller. It will never get to zero, but it will infinitely get closer to zero. I'm not quite sure what your question means. It will always be that simple. You will always have, it will always be very obvious whether it's tending towards infinity or zero, right? There are your two options. Okay, let's do another one. Okay, so this one's going to be a little bit cleaner, but it's the same idea. So this time, what I'm going to do is I'm going to write it slightly differently, right? So I would like to find 1 over x squared with respect to x. I want to find this as it tends towards infinity, okay? So 1 over x squared. So really what this is going to look like is I'm going to do that substitution letter thing, right? Whenever you have an infinity symbol, you just sub it in for another letter. Let's just use t. So what I want to do is find the integral between 1 and t. I'm going to rewrite this with respect to x. All right. So then I integrate this. What do I get? Negative x. Sorry, to the power of -1. And I'm going to go between t and 1. All right. So let's do that. So I'm going to rewrite this as -1 over x though, right? Because that's what this really means. So this is -1 over t minus -1 over -1. Is it not? Why do I have? That's not. What have I done? This should be positive. There we go. That's what I did wrong. Okay, so again, I want you to think of exactly what we just said before. What is this going to tend towards? As t approaches infinity, 1 over t is going to approach what? 0 again. So this is 0. And this is what? +1 because it's minus -1. So the answer to this is just 1. So these questions are asking us, let me just read out the exact wording of it to make life a lot easier for us. All right, they are asking things like, oh no, that's a different question. Let's not do that one. So, oh, right. So these ones are asking to find the value or find the finite value of the integral, right? So there's a couple of words I also want you to, so sometimes the question will say, hey, does this even have a value? Because sometimes actually the answer is it's undefined. You can't define the value. Let's look at an example where you can't define the value. Actually, no, let's do one more of those, but yeah, that's exactly what it's going to be. Let's do one more of these before we do that. Okay, I'm going to do it again. I'm going to go from infinity to 0. Let me do it in a second. Okay, so let's do this. Okay, I'm going to do the exact same thing. So first of all, I'm just going to rewrite this as 1 minus x to the power of -3. So how do I integrate this? This is where I need you not to forget stuff we've already done. What do I get? Okay, let's. Is that right? It's not.
It's not. Why you times it by the differential?
Good. This is the chain rule. The reverse of the chain rule. I also need to multiply it by the derivative of the brackets. So that's -1, right? Because it's just going to be, yeah. Okay, so then we have, oh, hang on. That's not right either. So now we have 1 over 2, 1 minus x squared. Are you with me? Okay. So what we want to do now is integrate that between, I should have been writing things over here, shouldn't I? Between 0 and infinity. But what I want to do is use another letter, right? So I'm just going to substitute in t again. So then I have 1 over 2, 1 minus 0 squared, right? Because 0 was up the top. So that's the number that goes first, minus 1 over 2, 1 minus t all squared. Now, again, I want you to use your sort of idea. So what does this become? Somebody said it before. Yeah, this is just half, right? Because that all becomes 1. 1 minus 1 is 0. 1 minus 0 is 1. 1 squared is 1. So this is just half. What's going on here? As t gets bigger and bigger and bigger, what is going on with this fraction?
Oh, the denominator is approaching.
The denominator is approaching 0, right? Well, but it's never going to be 0, is it? Hang on a second. Let me think about that. 1 minus, no, it's not.
No.
It's not. Sorry. This is 1 minus t. So whatever t is, it's going to be 1 minus.
It's approaching negative infinity.
It's approaching infinity, right? This is going to be going higher and higher and higher and higher all the time.
But negative in this case, right?
No, because you're squaring it,
Oh, okay.
right? So you square it, so it becomes positive again. So isn't this just tending towards 0 again, right? Because this number's getting bigger and bigger and bigger. Okay, which means the answer is half. Okay, let's look at an answer where it isn't defined.